today our learning goal says, I can divide decimals using the traditional method. In other words, not the 100 square grid, not the calculator, but good old what they call long division. Okay, setting up the division problem and working through it. Okay, so today, let's first of all though, let's talk about the 3 ways that division can be shown, and you should understand that this means I better divide, okay? So one way we show 10 divided by 2 is probably the most typical way that you will see it on a paper, right? 10 divided by 2. But another way we might see it is written as a fraction. 10, fraction bar means divided by 2. That's another way that you should say, oh, they mean I'm supposed to divide. And the last way is the setup for how we actually divide this. And we say we're going to put 10 divided by 2. There's the 3 different ways for us to show division. The other way, and they use this actually in the Eastern countries, they use a colon also, but I didn't really want to use the issue today with that. We can also write it like this. I'll just show it to you. You don't have to write it down. 10 to 2. That means division in the Eastern countries, not on our Western here. Okay, 3 parts to a division problem. There is what's called the dividend, the divisor, and the quotient. So in that 10 divided by 2, let's take that right there. Let's say, what would be the dividend in that problem? 10 divided by 2. Anybody know what the dividend is? Well, let's define it first. Which one do you think it is? You said it was 10, 2, the 2. It's actually the 10. It's actually the 10. So we're going to say the number being divided into. Number being divided into. It's kind of like our whole that we're going to find out how many parts can we take out of. Number being divided into. And in the case of the 10 divided by 2, and I've shown here what it's equal to. Do you agree with me that 10 divided by 2 is 5? Yeah. So in that problem, the dividend is 10. 10 is the number that is being divided into. It's the number that is like the start, the whole. And we're going to see how many 2's we can take out of it. So the divisor would be the number dividing by. So what number are you dividing by? What's that part that you want to know how many of them you can take out of? That's called the divisor. And this is math terminology that we should be able to recognize. So if they use those words in a problem, you know how to set the problem up. So number dividing by is the divisor. So what's the divisor in our division problem here? What is it? 2. It's the number we're dividing by. How many 2's can we take out of 10? And quotient, what's that? Anybody know what a quotient is? 5. It's the answer. Yeah, it's the answer to a division problem. The quotient is an answer to a division problem. And we can't just say answer. There's lots of problems that have answers. What's the answer you'll get when you do a division problem? That's called a quotient. So what's the quotient in our problem? 10 divided by 2 equals 5. 5, yeah, the answer. Okay. Or in other words, we can say there are 5, what? There are 5 2's in 10. There are 5 2's in 10. Okay, remember that we want to make sure we understand what dividing means. So when we're dividing, if the divisor is not, a whole number, okay, so if the divisor, would you circle that? The divisor is not a whole number. So So which number do we care about being a whole number?
The divisor.
The divisor, which is the what? The one we are dividing by, which in our other case was the 2, right? Was 2 a whole number?
Yes.
Okay, so it was a whole number. But if it's not a whole number, we need to rename both the divisor, and because you rename the divisor, you end up having to also rename the dividend. You can't just rename one of them because they're together in a problem, okay? So I have here 1 55/100 divided by 5/100. The divisor is a whole number? No. Our divisor is not a whole number, is it? So if it's not a whole number, we have to rename it so that it is a whole number. So let's write this as a fraction, okay? 1.55 over 0.05. Remember, division can also be written that way. We care about this guy down here being a whole number. What would we have to do to that 5/100 to make it into a whole number? Wait. Round? No. We can't really round because we got to do the same exact thing, and we would have to round the same amount. It's like, I don't know, that doesn't seem very easy to do for me. So it's not called rounding. I think you know what you mean, but you're just calling it rounding. Cheyenne? Move the decimal. Okay. How many places? 2 to the right. Moving the decimal point, and I don't want us just to move the decimal point without understanding what that means. Moving the decimal point 2 places to the right is the same as multiplying by what?
2.
No. When you want to move the decimal point 2 places to the right, that's the same as multiplying by 100. Yeah, that's really the same as multiplying by 100. So I want us to show that you have to actually multiply 5/100 by 100 to get it to become the whole number 5. Well, if you do that downstairs, you have to do it upstairs, the exact same amount. So 1 55/100 times 100 is, oh, for too long it would just get me to take the shortcut. 1 55/100 times 100 is 155. So I think for too long we've just been getting to move, and we don't really understand what's happening when we move the decimal point. Okay, so we gotta understand what's happening. We're actually multiplying by 100 to move the decimal point 2 places to the right. Whatever we do downstairs, do the exact same thing upstairs. This would become our new division problem. It would be 155 divided by 5. Okay, write that down. We're not going to divide it out right now. You don't want to know what the answer is. Right now we're just practicing renaming division problems. Practicing renaming. Now, notice, if you guys would have taken the shortcut that you learned, move the decimal point over 2, then you're going to move it over 2 in this one, would we have had the same thing? Yes, 155 divided by 5. And we would have had the same thing, but we have to have an understanding of why we can actually do that. Okay? So now I want you to, first of all, I want you to write that division problem as a fraction. What fraction would that be?
175, or 1 75/100 over 5/10.
Okay, 1 75/100 over 5/10. Which number do we care about being whole? The divisor, which once you write it as a fraction, it's the one up or down? Down. And so we care about that 5/10. We need to make it into a whole number. What would we have to multiply 5/10 by? 10. Good job. 5/10 would have to be multiplied by 10. If we multiply downstairs by 10, we have to multiply upstairs by 10. What's gonna happen when we take 1 and 75/100 times 10? Is it gonna be 175? 17.5. Or in other words, if we were just right now taking the shortcut that we learned, if we move this one place, we would move this one place, wouldn't we? It's 17.5, and it's going to be divided by 5/10 times 10 is? 5/10 times 10 is? 5/10 times 10 is? No. 5/10 times a 10 is? Helia? No? 5. It's 5. Again, we've been using the shortcut. Oh, look over here. If we would have used the shortcut, look what we would have gotten. Did we get 50? 2? All these other crazy numbers I was hearing? No, that's 5, isn't it? 17.5 divided by 5. Okay. So, when we set this up to actually divide it, when we actually do, I didn't want an equal sign there, I want an arrow. When we set it up, we would have the 17 and 5/10 getting divided by 5. Questions? We're not dividing them out right now. We don't care what the quotient is at the moment. What I care about is that we understand how to rename problems. Do you have a question on them? Okay, now let's go to the back side. We're going to practice 2 problems before I let you say we're done. Okay, we have 1 and 42/100 divided by 0 and 5/10. I've already written it as a fraction for us because now we're going to zero in on the what? Which one do we want to make sure is a whole number? The 1 and 42/100 or the 5/10? The 5/10. 5/10. What are we going to have to multiply it by? 10. Notice whatever I say in the name, that's what I multiply by. Tenths, I'm going to multiply by 10. If I multiply downstairs by 10, I have to multiply upstairs by 10. So upstairs becomes 14.2. And downstairs becomes 5. So now I really have the problem 14 and 2/10 divided by 5. And we're going to come over here and do it, okay? 14 and 2/10 divided by 5. If you don't have a whole number on the outside here, don't carry on. Don't start dividing. You're not ready. Okay, you guys remember long division? Yeah? Kind of goes something like this. You just start looking at the digits. Can 5 go into 1? No, so I can just stick a 0 up there. It goes in 0 times, right? Or I can ignore it and not put anything there. So now I move over and I put the 1 together with the 4. Can 5 go into 14?
Yes.
How many 5s can you take out of 14?
2.
2. So we put a 2 above the 4. And does it matter that we're lining this up nicely? Yes, it does. What's 2 times 5? 10. So I line up a 10 under the 14. Am I going to add or subtract?
Subtract.
I'm going to subtract. How much is left? 4. But before I move on, I say, you know what? I got a decimal point next, don't I? So we need to take it straight up and put it right there before we even carry on. Okay, now what are we going to do? Sierra? Now we bring down the 2. We say we all actually are going to have 42 now. How many 5s can you take out of 42? Caden? 8 of them. So we put an 8 here. And what's 8 times 5, class? 40. Add or subtract? Subtract. What do I have left? 2. Okay. Are we done?
No.
We're not done until this is what? Until this is what? 0. So we have no remainder. We have a remainder yet, don't we? So we would keep going. What do we do to keep going? Add a 0 where? After the 2 up here?
Yeah.
Okay, so I'm going to add a 0 after this 2, and what am I going to do with that 0? I'm going to bring it down. Okay, so I now have 20. How many 5s can you take out of 20? 4, so I put a 4 up here. 4 times 5 is? 20. 20 take away 20 is?
0.
We're done, aren't we? Okay. So our answer is, the quotient is 0.284, which we could clean up and make 2 and 84 hundredths. Good job. Okay, let's see if this answer makes sense. Remember, we don't want to just do it and get an answer and be happy that we have an answer. We want to say, how could we make sense of this answer? So, if we rounded 1 and 42 hundredths, the dividend, to 1 and 5/10, if we rounded it up to 1 and 5/10, 1 and a half, how many times could we take 5/10, also known as 1/2? So let's think of this as money. How much money is that? 1.5? How much money is that? $1.50. So if we make this $1.50 and we divide it by, what's 0.5 in money? 50 cents, right? Not 5 cents, 50 cents. 5 cents is 0.05. 50 cents. How many times can you take 50 cents out of $1.50? 50 cents plus another 50 cents is $1, plus another 50 cents is $1.50. It looks to me like you can take it out 3 times. So about 3 times. And our 3 is close to our quotient 2 and 84 hundredths, isn't it? Would 2 and 84 hundredths round up to would the whole number it rounds to be 3? Yeah. So it seems like we have a good answer, doesn't it? Okay, making sense of it. So anybody want any part of this, you want to go back and say, I don't get that. Just own up to it now because you want to get it now. Because you can't use your calculators to do this. You can use your multiplication grids, but you can't use your calculators. No questions? No concerns? No beefs? No nothing? Okay, let's move on then. Okay, what are we going to do first here? Write it as a fraction. 0 and 12 hundredths divided by 0 and 59 hundredths. Which one do we care about being a whole number?
12.
The divisor, the downstairs, the divisor down there. So we want the 59 hundredths. We're going to multiply by 100. Thank you. We're going to multiply by 100. If we do that down, we have to do it up. Okay? 12 hundredths times 100. 12. 59 hundredths times 100. 59. So our division problem really looks, we just renamed it as, where's the 12 go? In or out? Out. And where's the 59 go? In. Okay. 59, or if I just did it wrong. Did I even say it wrong there? 12 divided by 59. We might have just said that wrong. Okay, because here's what happens, and I just did it too with you. We always think the bigger numbers on the inside, don't we? But it doesn't have to be. So we gotta be careful we don't make that mistake. So we actually have, let's go over here and divide now. We have 12 being divided by 59. Well, tell me something. How many 59s do you think you can take out of 12? Any?
No.
No. So our number is going to be less than 1, isn't it? Our answer better be less than 1 because you can't take any 59s out of 12. Yeah, it's just not possible. So when we're done with this, we better have an answer less than 1, somewhere between 0 and 1. Okay? So can 59 go into 1? No. Can 59 go into 12? Okay, so we get zeros up here, don't we? Well, now what? We just quit them? No, we put a decimal point here first. Because there wasn't one, right? So we have to put a decimal point. We're going to carry it up here also. And then we're going to stick a 0 there. Okay. Now we can say how many times can you take 59 out of 120? Anybody know? 2. Okay, so 2 times. What is 2 times 59? 118. And we need to subtract. It's 120, take away 118. 2. Do we have a remainder of 0 yet? No. So what are we going to do?
Add 0.
Add another 0, bring it down, right? Okay. So now we have 20. How many 59s can you take out of 20? 0. Okay, well then we're going to put a 0 up there. And what are we going to have to do?
Add another 0.
Add another 0. And now we'll bring that one down. So now we have 200. Can we take some 59s out of 200?
Yeah.
How many about? Think we can take 4?
Yeah.
4 times 50 is 200, isn't it? Well, we got 59. So can we take 4 out? I think we can only take 3. Let's try 3. Sometimes you might, sometimes you might just find out that you got a number bigger than 200 when you multiply. You got a number that you should have taken more out. So anybody know what 3 times 59 is? 177. How much is left? How much is left? 23? Okay, thank you. Is that what I heard? 23? 33. I think it's 23.
It's 23.
I think I might have to overwrite it and say it's 23. Okay, does this one look like it's gonna maybe end ever?
No.
Do you think this is maybe one of those that's got a repeating decimal?
Yeah.
Probably. So once we've taken it out 3 places, I'm gonna let you stop and say, you know what, even though we don't have a remainder of 0, we're gonna round. Write this in your notes here. Round to hundredths. So if you've taken it out 3 places, you get to stop and round it to hundredths. Instead of going on forever and finding the repeating pattern, we're going to say we have 0. Do we need both zeros in front of the decimal point? No, we have 0.203. That's what we're going to round to hundredths. So what would that be rounded to hundredths? Cheyenne? Yeah. So this 3 is not big enough to change 20 hundredths to 21 hundredths. That's how we could read it. We have 20 hundredths here. That 3 is not big enough to make it 21 hundredths, so we're going to say 0 and 20 hundredths is our quotient. So we're going to say that 0 and 12 hundredths divided by 0 and 59 hundredths is approximately equal to, we need that squiggle equal sign now, because we're rounding, we quit, we said enough. And we're saying this is approximately what its answer is. So we're going to make a little conclusion here. Were we taking a smaller number and dividing it by a bigger number? We were, weren't we? So we can count on that when we divide a smaller number by a larger number, what's going to happen? What's our quotient going to be with relationship to 1? Bigger than 1 or less than 1? Less than 1. And we started talking about that at the beginning. We said, when I asked you right away in the start, how many 59s can we get out of 12? You said none, right? So we have to end up with a number less than 1 when we're dividing a smaller number by a bigger number. Okay, questions? You're going to be able to do this, right? Got it? Okay.